Welcome to Tech Talk Today, where we dive into the latest in technology and innovation. I'm your host, and today we have Dr. Emily Carter, an expert in artificial intelligence, joining us. Dr. Carter, thanks for being here.
Thanks for having me. I'm excited to chat about some fascinating insights into artificial intelligence.
Let's jump right in. I've heard that intelligence in AI can emerge from complexity, not just from intelligent data. Can you explain what that means?
Absolutely. It's a bit like teaching a child. You don't always need to give them complex lessons. Sometimes exposure to a rich environment is enough. In AI, we've found that when models are exposed to complex systems, like elementary cellular automata, ECA, they can develop higher levels of intelligence. It's the complexity itself that fosters learning, not just the data.
That's intriguing. So what exactly are these elementary cellular automata?
Great question. ECA are simple, rule-based systems that can generate surprisingly complex behaviors. Imagine a grid of cells, each either black or white. The color of each cell in the next generation depends on a simple set of rules applied to its neighbors. Despite their simplicity, these rules can create intricate patterns, much like the complexity we see in nature.
And how does this complexity influence AI models?
When we train AI models on these complex systems, they learn to navigate and predict these intricate patterns. It's like exercising their cognitive muscles. The key finding here is that models exposed to higher complexity rules tend to exhibit greater intelligence. However, there's a catch. Too much complexity or chaos can overwhelm the model, leading to poor performance.
So, there's a balance to be struck. How do you find this sweet spot of complexity?
Exactly. It's what we call the edge of chaos. It's the point where there's just enough unpredictability to challenge the model, but not so much that it becomes random noise. We use various complexity measures, like Lempel-Zeev and Lyapunov exponent, to identify this balance. It's like tuning a radio to the right frequency.
Fascinating. What are some of the challenges you've faced in this research?
One of the main challenges is understanding how these complex, rule-based systems influence model capabilities. Chaotic systems can be too random, making it difficult for models to learn effectively. It's a bit like trying to learn a language by listening to static.
How have you tried to overcome these obstacles?
We've experimented with modifying architectures, like using a version of GPT-2 adapted for binary input and output to predict ECA states. This helps the model better grasp the underlying patterns without getting lost in the chaos.
What broader implications does this research have?
It opens up new perspectives on how intelligence might emerge in artificial systems and even offers parallels to human cognition. In business, it suggests that instead of focusing solely on data quantity, we should consider the complexity of data. This could revolutionize data curation practices, emphasizing quality over quantity.
That's a game changer. Any future directions you're excited about?
Definitely. We're looking at applying these insights to develop more robust AI systems that can adapt to complex environments. It's about creating AI that can learn like humans by interacting with and understanding the world around them.
Thank you, Dr. Carter, for sharing these insights. It's been a pleasure having you on the show.
Thank you. It's been great discussing these exciting developments in AI.